Hey guys, I just wanted to leave you a few notes on ideal gas law variations, and there's really just one formula that we use that is a variation on this ideal gas law that we learned yesterday. Okay, so you have these notes, you took these notes, these are your R's or your ideal gas constants, and I just want to remind you that N is moles. Okay, so if I were to give you grams or particles, you have to convert that to moles before you plug it into PivNert. Okay, and then your R you pick based on your pressure unit. So if your pressures are in ATM, you would pick this R, 0.0821. kPa this one, mmHg this one. Okay, that's a 4. And I also just want to point out, I didn't do this yesterday, but your units for your R constants, it's just PivNert rearranged, right? So there's your volume and your pressure divided by your moles and your volume. Because if you were to do that, if you were to divide by moles and temperature, if you were to divide by NT and NT to isolate the R, that's what you would get. Pressure and volume over moles and Kelvin, or moles and temperature. So, moving on to ideal gas law variations. So we won't always want necessarily the volume or the moles. Sometimes we might want the molar mass or the density. So the formula, it's very similar to PivNert. But write this down and know it. It's P times the molar mass. I'm going to do that with a capital M. Sometimes you might see it with capital MM. Equals density times R times temperature. So it's the exact same as PivNert. Instead of the volume, it's molar mass. Instead of the moles, it's density. Okay? So you could arrange this in a couple of different ways to isolate either molar mass or density depending on what you're solving for. And let's take a second and make sure we write down those variables. D is density. And remember, density is mass divided by volume, or grams divided by liters. Okay, so if you see in a problem grams and liters, but you're being asked about molar mass, you're using this ideal gas law variation, and you're going to plug in your mass and volume to get density. Okay, that's actually the practice problem that I picked for me to do with you on this video has that situation. Before we do our practice problems, which, by the way, the rest of class, I want you to finish some of these ideal gas law problems, the basic ones. So 3, 4, 6, 7, 8, and 9. Okay, that's 1, 2, 3, 4, 5, 6 problems. And then we're going to do 14 together right now, and I want you to also do 15 and 16. Okay, 17 is an extension. I haven't even worked it yet. Looking at 17b, I would need to sit and think about that. Okay, so if you want to attempt 17, go for it. So before we start that though, I just want to be sure you've seen this on the very last page. These are all of your gas laws. Okay, here is your constants. Here is your pressure and temperature conversions. Here's your ideal gas law that we learned yesterday. This is that ideal gas law variation that we just wrote down. It's just rearranged. Okay, we wrote it like this because I wanted to show it to you basically in the same format as PivNert, but your formula chart has it written like this. It's the same formula. It just has molar mass isolated. Okay, here's all of your gas laws. Here's your standard molar volume. We haven't talked about this yet. That's actually going to come in the next day or two. Dalton's law, Graham's law, which we haven't done yet. So that's on the very last page of your packet. Again, guys, numbers 1, 2, and 3 were homework last night. The rest of class after this video, I want you working on 3, 4, 6, 7, 8, and 9. and then 14, 15, and 16. We're about to do 14 together. Okay, so it says, let me kind of make room for everything here. It says, what is the molar mass of 0.65 grams of gas occupying 1.12 liters at 280 Kelvin and 1.14 atm? So at first glance, it seems just like PivNert, right? You got your mass, which you could convert to moles. You got your volume, temperature, pressure, but it wants molar mass. Okay? The minute you see the word molar mass or density, you need to use the molar mass variation. Okay? Either this formula or the one that's on your formula chart. Like that. Okay? So we're solving for molar mass of 6.50 grams of a gas occupying 1.12 liters. This is density right here. Grams per liter. Mass divided by volume. So we're just going to plug in numbers. Okay, pressure is 1.14 atm. I'm solving for the molar mass. Density, I wasn't given a straightforward number, but I know that if I divide the mass by the volume, that gives me density. Okay, my R value I pick based on my pressure, which was in atm, so 0.0821, and my temperature, whoever wrote this packet was nice enough to give it to us already in Kelvin. Okay, so now we need to solve for molar mass, and you can do this a couple of different ways. You can go ahead and solve for the density and just put in one number there, or you can get 1.12 out of the denominator and solve it that way. Either way gives you the same answer. Okay, so if you were to solve density first, 0.650 divided by 1.2, is it 0.065? 0.65 divided by 1.12, that gives you a density of 0.580. So that's what you would plug in there. Or you can get 1.12 out of the denominator, and we do that by multiplying both sides, right? And that cancels that out. This is sloppy. And then you multiply 1.12 times 1.14. That gives us 1.27. Okay, I still have 0.650 because I personally went about it by getting 1.12 out of the denominator, and now I need to isolate molar mass, so I divide both sides by 1.27. That cancels out, and then I just plug and chug. 0.65 times 0.0821 times 280, divide by 1.27, and I get 11.765. How many sig figs am I working with? 3, 3, 2, and 3. So I need this in 2 sig figs, so 12. And then my units for molar mass, do we remember? Think to yourself really fast, what are the units for molar mass? They are grams per mole. Okay, so we could take it a step further. You could even identify your element based on that molar mass. So you would just find who was closest to 11.7 or 12. Okay, so it looks like we're probably working with carbon there. Or could that be a diatomic? Is there a 5.88? Not really. So anyway, you could also identify something based on its density if you were given a chart of known densities. So hopefully that makes sense. That's about as complicated as this one would get, being that you were not given the density. You had to plug your mass and volume into density. Uh-oh, did that go black on you guys? I hope not. So again, just to reiterate, you've already done from section G 1, 2, and 3. The rest of class, you are working on numbers 3, 4, 6, 7, 8, 9, and then 15 and 16 from section F. Okay, the key is on It's Learning. It is like straight at the top of this week at the glance, and you are free to listen to music, work with your partners, whatever you need to do. Have a good day, guys. Bye.